Welcome to The Transit of Venus, a tale of discovery and science. Are we excited? Thank you. I'm joined on stage by two guests. The first is Susanna Hellman from the National Library of Australia, and also Paul Floyd, who's a local astronomy educator from here at Canberra. We also have a couple of presenters watching via video conference who will speak to you all in just a moment. Firstly, Paul Brunton from the Mitchell Library, part of the State Library of New South Wales. Hi, Paul. Hello. And also Scott and Sarah from the Museum of New Zealand. That's Te Papa Tongarewa over in Wellington. Hi, Scott. Hi, Sarah.
Kia ora, Nat.
Kia ora. And later we'll also chat with Carlos Bacigalupo, and he is on the HMB Endeavour replica as we speak on their way to Lord Howe Island. He's from the Sydney Observatory and he's the astronomer on that ship. So we'll cross to him soon to say hello. Now, I think to start us all off, I will introduce you again to Paul Floyd. Come on up, Paul. Paul's going to tell us what the transit is and why it's so important to us. Thank you, Paul.
All right, thank you. Okay, the transit of Venus is basically the planet Venus going in front of the Sun. It's very rare. It happens only twice every 240 years. Only ever been seen six times since 1639, so very, very unusual, and it's happening next Wednesday. So if you're lucky enough you have prepared some safe viewing equipment, you can actually watch it between 8:15 and 2:45. Now, the reason why it's rare is quite interesting and quite unusual, and I need a volunteer to help me set up a solar system. Now, Nat, do you want to choose? Oh, you're going to be a volunteer.
Who have we got? Hello, what's your name?
Andel.
Andel?
Yep.
I'll get you to hold on. This Paul's going to help you out with that.
All right, now I'll hold it for a second. Now, what I'm going to get Adele to do, and I'll just hold it and do some pointing. What we've actually got is Adele's going to be the Sun. We've got a model of the Venus and its orbit, so the green hoop's Venus's orbit. Now, there's a couple of reasons why the transit's so rare. First of all, it's got to do with the difference between Venus and the Earth zipping around the Sun. Think of Venus as a super fast racing car, and we're a fairly fast racing car, but not quite as fast. So if I'm going to get Adele to hold Venus in its orbit nice and straight, like that, and basically, if we imagine Venus zipping around the Sun every 225 days, the Earth, and everyone in the audience here is going to be the Earth, you're looking at Venus. I might actually tilt so we don't see a transit, so Venus is not going in front of the Sun. Basically, let's just go back a bit. For you in the audience to actually see the transit, Venus basically has to be in the right spot in its orbit. Now, because we're zipping around at different speeds, that only happens every 550 days. There's a catch though. Venus's orbit's actually tilted 3 degrees. So most of the time when Venus is actually in a line with the Earth, it's actually either above or below the Sun, and so that's why transits are quite rare. So if you miss the one next week, you've got to wait till 2117 to see a transit. So hopefully we'll have clear weather. All right, thank you, Adele.
How about a clap for Adele?
Okay, take off. Now.
Okay, so back during Cook's voyage, the voyage of 1769, when they were observing the transit, what were they hoping to achieve?
Well, we take it for granted that we actually know that the Sun is about 150 million kilometres away, what's called an astronomical unit. Basically back then they didn't, and they wanted to know how far it was away. So astronomers were quite clever, and they worked out that if we can work out actually how far, how quickly Venus is travelling in its orbit, and we can time that, they can compare the observations between different points on the Earth's surface and then work out how far Venus is away, and then they do a skip and work out how far away the Sun is from the Earth. So it was an unknown at that time, working out how far away the Sun was.
Okay. So they could use those calculations then to figure out how big our solar system is?
That's right, yep.
Excellent. Well, we've got a couple of other guests here today who are going to talk more about the voyage. Let's thank Paul for now, and we'll cross over to Susanna. Okay, so Susanna Hellman is from the National Library of Australia, and tell us what you've got over there about Cook.
Well, just recently, just last October, we opened our new Treasures Gallery, which has material relating to Cook's 3 voyages. So I'll just link to a video now that was made last week of our new Treasures Gallery, and you'll see Nat Williams, our Director of Exhibitions.
Welcome to the National Library of Australia and our new Treasures Gallery, which opened about 8 months ago. In the case behind me are 3 remarkable documents. The first is Cook's Endeavour Journal, the central document, which is 750 odd pages long, his longhand written account of his voyaging and his experiences. On the left-hand side here is the additional instructions, or so-called secret instructions, which were given to Captain Cook, or Lieutenant Cook as he was at the time, by the Admiralty, which was the primary overarching body that controlled the Navy. And on the right-hand side here we have, in a smaller document, very beautifully handwritten, what's called Lord Morton's Hints. Lord Morton was the President of the Royal Society, and he gives these hints to Cook, Banks, Solander and others that voyage on the Endeavour. He's basically saying, if you venture beyond, he was aware that the idea was to go out, see the transit of Venus, but then voyage further to possibly identify the Great South Land. If you encounter native peoples, treat them with kindness, don't surprise them, by all means engage with them, but don't usurp their land without obtaining their permission. Now Captain Cook and crew, 94 people, are to progress to Tahiti, which had been discovered by Wallis 2 years earlier, and on the Dolphin. And they go to the point that Wallis had identified Matavai Bay, subsequently named by Cook Point Venus, to observe the transit of Venus. But having felt that the transit of Venus was possibly not the success that it might have been, he could have gone home. I mean, his instructions, the secret instructions, were essentially followed to the letter. He also had the problem of the difficulty of a southward passage home at that time of year, so he decided that he would go via the East Indies, which meant that he would have to go to the north. So in doing that, he progresses to the west and finds, of course, Australia. Here in the Treasures Gallery, in telling the story of Cook, we have, obviously behind me, this extraordinary painting by Carter of the death of Cook. We also have the earliest known portrait of Cook in oil in 1771. We also have things like his desk, which was carried from ship to ship, and he would have written the journal, the Endeavour Journal, on, and artefacts that were connected with him, his fork, his walking stick, a box of instruments that he used on board ship, and a variety of paintings which also tell the story or some of the moments of the second and third voyages.
Nat makes a really important point, I think, in there in terms of how important the transit of Venus was to Australia, because it's basically because of that journey that he took that he was able to map the east coast of Australia, which is pretty important to the way that I guess that we saw it back then. But Susanna, reading the journal, that's a pretty personal thing. I'm not allowed to read my sister's diary. What sort of things can we learn about Cook from reading it?
Definitely. Well, basically the journal, which is now just in one volume, when Cook actually wrote it, it was in quite a number of different small booklets, like you might have with your exercise books. Basically, the journal shows that he was someone who didn't use flowery language. He was very to the point. He was really meticulous. We know that he was a man of science, and it's really because of his chart making, his map making skills that he was chosen for this voyage. So from this journal, we really can see the man and how he experienced it. The particular entry for the Transit of Venus Day is actually really quite short, which you would expect from a man who's been at sea. He hadn't had a lot of education. He had educated himself in science, but he'd been at sea for years. And I'll just read out a little bit and you'll get a really good sense of it, of how he experienced it. This day proved as favourable to our purpose as we could wish. Not a cloud was to be seen the whole day, and the air was perfectly clear, so that we had every advantage we could desire in observing the whole of the passage of the planet Venus over the sun's disk. So you really get a great sense that it was fantastic weather on the day of the transit of Venus. And equally, he's just as brief when he says why it all didn't work as well as could be hoped. And I'll just read out that sentence too. We differed from one another in observing the times of the contacts much more than could be expected. So that was really, here you have in this page of the journal, everything in a nutshell.
Okay, so we're talking about, so they thought that their observations of the transit was a failure. And one of the reasons is because, actually Paul could probably help us out with this one. There was many people looking at the transit at one time, is that right? Yep. And their observations differ. I think what he's referring to John Gore's observations in that journal passage?
Yep. They actually had a number of, apparently 3 observing sites set up, and essentially they needed to have the observations accurate to ideally the nearest second, which was quite remarkable for back then, given how poor timekeeping equipment was. So essentially the problem is that the observations differed by up to 15 or 20 seconds, and from a scientific point of view, trying to measure the accuracy of the distance to the sun, that didn't work. 2 possible reasons. One was 3, clocks weren't very good. Second one was the telescopes weren't particularly good, and the other one is the black drop effect, where and basically what they had to do for the observations to be accurate, they actually were looking at when Venus moved in front of the disk of the sun, and they had to get that exact second. And what they discovered is the black disk of Venus seemed to actually merge with the outer blackness of space surrounding the sun.
Okay, we've got a demonstration that will help everyone to understand kind of what was going on with this black drop effect. So what I'm going to get everybody to do, so here in the theatre, and also anybody watching by video comments, you can do it at home too, is everyone put out their hand. So we put out our hand and we're going to use our thumb and our forefinger. And if you put that out towards a light source, so perhaps from everyone here in the theatre, put it up towards the screen or the light, and gradually move your thumb and forefinger close together. Now what you'll eventually see is it'll seem like they're touching before they actually are. So there's a slight moment there where there's something what they call a ligament. So there's a slight black, kind of maybe it looks like a shadow, maybe it just looks like you've got a little extra teardrop coming out of your thumb, and it makes it appear that it's touching when it isn't. Now, what was really important, as Paul said, was that they knew the precise moment when Venus touched or crossed the very edge of the sun, and also when it left out on the opposite way. So that made it really hard for them to see. Thanks. Yep. Okay, well, Susanna mentioned that the entry in the journal was really short, Cook's entry about the transit of Venus, but we have somebody over at the Mitchell Library, which is part of the State Library in New South Wales, Paul Brunton. And Paul, I believe you've got some more written observations of Cook. Can you tell us about what you have in your collection there?
What we have in the collection is the actual observations of the transit of Venus that Cook took, and I think you can see that on your screen now, or it's coming up. You see how he's observing the different phases of the transit as Venus touches the sun and then touches the rim of the sun, or seems to touch the rim of the sun and moves across then. So we have there, you can see it's headed transit of then the sign for Venus, Saturday, June the 3rd, 1769. And on the other page, he continues, and you can just see at the end his signature, James Cook. Very strong signature, very clear signature. And in a way, this document is the very beginning of the settlement of Australia, because, as we've heard, the observation of the transit led directly to the settlement in Australia. Although it took a while and it was by no means certain, Cook showed his greatness in having followed all his orders, having observed the transit, and then having sailed south to see whether there was any Great South Land, and having concluded that there wasn't, it was thought that there had to be a Great South Land, otherwise the world would tip over, because there was a huge landmass in the north, there must be a huge landmass in the south. So he'd sailed south, he'd shown there was no Great South Land, he'd proven that New Zealand was 2 islands, it was not part of a Great South Land, and he could have gone home, but he didn't go home. He'd finished all his orders, and what made him great was that he went the extra mile, because he knew now that if he sailed west, sooner or later he had to meet the eastern extremity of that great landmass the Dutch had discovered, which they called New Holland, which was basically Western Australia. And that's what he did. And so he sails west, charts the east coast of Australia. That in itself may not have led to the settlement in Australia, but on board was Joseph Banks, a young man who was going on his grand trip around the world. And he was the man who recommended that the east coast of Australia be the place where the convicts were sent. And so that is what happened in 1788. So there was a number of what-ifs of history, if you like. It was by no means certain they could even observe the transit from Tahiti, because they didn't know about Tahiti until just before they needed to leave. So if Tahiti had not been discovered in time, they may not have been able to observe it, even in the South Seas. And finally, this is his sword. This is what's called his dress sword. He would have worn this when he was presented to the king after the Endeavour voyage. It was a ceremonial sword that naval people wore on official occasions, ceremonies, parades, and of course meeting the king.
Well, we might take the time now to cross to New Zealand. So it's the Museum of New Zealand in Wellington, Te Papa Tongarewa, and we have Scott and Sarah, who I think are going to talk to us a little bit about Cook's maps. What have you got, Scotty?
We do have a bit of stuff about some of Captain Cook's maps, because like Susanna said earlier, he had some really good skills at making maps. He was a very extraordinary map maker, and we've got some of the maps that he made over 200 years ago, and we can kind of compare those to the maps that we've got today, and we can see just how accurate and precise those maps were. But before we do that, it kind of ties in nicely to the last question from Ballarat, and we've actually got a copy of Abel Tasman's map, so we can kind of see what was missing, and then we can kind of see the gaps that Cook filled in. So what we're going to do is we're going to have a look at that map to start with, and you can see from this map, so you can see the bits of Australia that were already mapped by Abel Tasman, and like Paul mentioned, that whole east coast was missing. So nothing was known. I didn't know how far across the coast was or how big the land was. So you can kind of see the gaps that were there, and Cook went ahead and filled those gaps. So the first country he got to, and Sarah's going to help change these images over for us, the first country he got to, or the first land that he came to, was New Zealand. And that's a very modern map of New Zealand. So that's the shape of New Zealand that we know it to look like today. You can see two islands, and clearly not a huge continental landmass, so it wasn't the great southern continent that they were looking for. But we've now got Cook's map over the top. I'll just zoom out a little bit so we can see the whole thing. And you can see the map that Cook made nearly 250 years ago is almost as accurate as the current maps that we've got today. So Sarah can take that one away again very quickly. You can see very, very precise and very close to what we see today. And we're going to have a look at one more map he made of New Zealand before we go over and have a look at his maps of Australia. So we've just gone a little bit closer now on the North Island of New Zealand. So I'll zoom back in. And you can see very kind of clearly mapped, and you probably can't read the names, they're quite small, but what's also very interesting is a lot of the names that Captain Cook gave these places are still the names that we use today. So, for instance, you probably can't see, I could probably zoom in a little bit more, and down here you can read Hawke Bay over here, Bay of Plenty up here, and we're going to put a new map up. You can see the same shape of the coastline, the same names still being used today as it comes into focus. So same bay here, Hawke Bay here, and Bay of Plenty up there. So very, very accurate, and we're still using the same place names that Cook used today.
I understand that you have in your collection a cannon from the Endeavour, is that right?
Yes, now that's correct. A cannon that we have in our collection here in New Zealand, and it was a gift from Australia to Te Papa.
We also have a cannon here in Canberra, which is held at the National Museum of Australia, and we've got a little video. We went over there last week to have a look at the Cook collection at the National Museum, and we had a chat with Michelle Hetherington. So how about we have a look at that video and see what they have there in the collection.
Hello, I'm Michelle Hetherington. I'm a senior curator at the National Museum of Australia, and I'm here talking to you about the Cook collection that the National Museum has. One of the most beautiful objects, as far as I'm concerned, in the collection is John Gore's telescope. Now, this is a telescope that he used to observe the transit of Venus from the island of Moorea in 1769. Now, other beautiful things in this case include the plane table frame. The plane table frame was used during Cook's voyage to observe the transit of Venus, and of course was of great use when he was circumnavigating New Zealand and plotting the coast, the east coast of Australia. So after Cook had observed the transit of Venus, he had a few other things he had to do for the Royal Navy and the Royal Society. Then he decided that he would come home. They're getting low on stores, they've been out for 3 years, and on the night of June the 11th, disaster. They strike the reef at 11 o'clock at night. Cook had already gone to bed, and there's an account in one of the journals that he appeared on the deck in his underwear and began to direct operations. They had to man the pumps, they began to throw all the heavy things overboard, including 6 huge cannon. And they managed finally to winch themselves off the rock after 23 hours. They put a bandage under the ship made out of a sail, which they'd filled with sheep dung and other disgusting material from on board ship, and then they limped in to coast. It took them nearly a week with a leaking ship. Now, the cannons were known to be there because, of course, Cook plotted their position as well as the anchor that he had to cut loose, because of course it's government property. He's going to have to go back and get it perhaps. And so people knew they were there, but nobody could find it until 199 years later. So one of the things that made Cook so famous in his own day were his maps. They really were superb, and they were being used over a century or more later. Now, in this case, there's a beautiful pair of embroidered map samplers, and in the 18th century, girls who went to school were often required to learn both geography and needlework, and these two tasks are combined in the map samplers. One of the students has used a map based on Cook's 3 voyages, and with her needle she has carefully followed his route across the seas, and I find it a wonderful object because, of course, the girls were not allowed to go to sea at the time, and here's a girl following in his path in the only way she can.
So one of the things that Michelle spoke about was this plane table frame. It's actually a collapsible frame, wooden frame that you stick around like a platform, so it becomes a portable table, and that frame has numbers on it, so measurements, so that it helps you to make accurate maps. So that was really important to Cook being able to make those beautiful maps that he did. We have our astronomer on the HMB Endeavour right now. He's called in. We're going to cross to him now. Carlos, whereabouts are you?
Hello, good afternoon everyone. I'm in the HMB Endeavour. We are about 5 miles off the shore. We are pretty much in front of Dee Why right now, so that I can see still Sydney in the distance. We're not too far.
Carlos, can you tell us what you're aiming to achieve on this voyage?
Well, in the Endeavour right now, we are learning how it used to be the experience of sailing in a square-rigged sailing ship. It's a great experience. It's a very hands-on experience. So not long ago, about 2 hours ago, I was about 20 meters hanging from a mast while having helicopters filming us. So it's been a very glamorous exit from
You yourself were hanging from the mast of the Endeavour.
That's right. Me and many other people with the same experience than I have, which is 0 until yesterday.
So you're on the boat as the official astronomer for the Sydney Observatory, but it's pretty important to know everybody on that boat has to also do some other work. Is that the case?
That's right. That's right. This is officially a cargo ship, so it can't just take passengers. Only a very few number of passengers, and the rest of us have to act as crew. So we have to be trained properly and do crew work, which includes literally climbing to the top of the mast and setting the sails free and these kind of activities, which are a lot of fun and a lot more challenging than what they look like from the distance.
So you're going to be observing the transit of Venus next week on the 6th of June. Can you tell us a little bit about that, what you'll be doing with those observations?
Yes, we have set up a telescope that's going to be connected to a camera, and that's going to be feeding live over the internet, and that's going to become a bit of a backup plan for any other place in the world that may have cloudy skies and would like to take that feed. That's organized by the Sydney Observatory and the Maritime Museum, and that provides a secondary option for somebody that's trying to observe it and luckily might not be able to. And next to that, we're going to have a telescope set up with a solar filter, and we're going to use that for direct observation. We are going to allow all members that are going to be in the area to look through the telescope and in a safe way and be able to see the planet entering the disk of the sun and basically crossing it over the 6-hour period that the transit lasts.
So you can see the transit of Venus on the internet. So Carlos is involved in a project. They'll be filming it using a special solar filter, if I heard correctly. And we're going to talk about viewing the transit safely in a little while. But it's a good point for everyone to know that you can actually observe this over the internet if you need to. It's tov.anmm, Australian National Maritime Museum.gov.au. We all know not to look directly at the sun. And there are a few reasons for that. The main one being that you can hurt yourself. The UV radiation can damage your eyes. It's electrical signals going to your brain, get interrupted. It's going to... Don't be like the 3 blind mice. And we've got a quick demonstration now to show you how you can view the transit of Venus without looking at the sun. And Paul's going to run us through that. Should we stand up and have a look over here, Paul?
What I've got set up here is something that you can rush out, go to your local shop. This was bought from a discount retailer for $50. And basically, it's a telescope to actually project image of the sun. So you, under no circumstance, actually look through the telescope at the sun. And if you're a school teacher, you're going to have to make sure that if you set this up in your school, that the telescope is actually always supervised, because you always have at least one person who actually tries to look through the telescope. It's happened. All right, very easy to make this whole process safe. You can't actually see from the camera angle. First of all, there's no finder scope on the telescope. Instead, what I've got is a piece of cardboard which I've put on the front as a sunshade. Now, you're observing as simple as, once the eyepiece is in, pointing at the sun, and with the telescope in the right spot, you actually end up with a lovely image of the disk of the sun. On the day next week, you actually see Venus travel, and unlike the charts where it goes across the bottom, because a refractor telescope inverts the image, Venus will actually travel across the top, as seen here. Now, a little tip for you to save you actually looking, or save you from the need to look through the telescope to find the sun, I've actually got at the front a little hole, and basically what you end up, if we have a look at the flip chart I've got here, there's actually 2 images of the sun.
This is the hole you're talking about here. You put in the cardboard, and that reflects. So that's what this blurry patch is.
Yep, with the real sun, it'll actually be a nice sharp dot. So basically, you can actually look for that dot on your white piece of paper, and that'll show you that you've got the telescope in the right spot. And then it's a case of just wiggling the telescope around until you see the proper image or the disk of the sun. And the transit will be very easily visible as a black dot going across. I should say, sorry, black disk, a little black disk going across from one side to the other of the sun.
I'm going to have to wrap everything up. I'd like to say thank you to everybody for watching today. The schools here in our live audience, those joining us by video conference, thank you for your wonderful questions. Everyone watching on the live internet stream, thank you for tuning in. I'd also like to take the time to thank our guests, Susanna from the National Library. Yeah, let's give them a hand. Michelle at the National Museum, the Mitchell Library, Paul Brunton, thank you so much. Scott and Sarah from Te Papa. Also, thank you to Carlos. He can't hear us right now, but Carlos from the Sydney Observatory and the National Maritime Museum. Thank you. And don't forget, you can tune into our other live at Q events by watching our live stream. You can also find out what events are coming up by having a look at our website. And that's www.questacon.edu.au/live. And if you've got any questions from today's event that we didn't get a chance to answer, please send us an email. Again, that's live@questacon.edu.au, and we'll try our best to get them to the people who know the answers, or we'll have a bash at them ourselves as well. So thank you all for coming along. Before you all leave, everybody here in the audience, we have some gifts for you. And there's somebody at the front door, Phil Hoare has written a book about the transit, so if you get a chance to chat with him, please do that, and he'll hand you some posters. Everybody else, thank you so much again for watching, and give yourselves a clap and a warm.